This is a brief introduction to Module 2, and we're going to be looking at special cases of differential equations. In the first case, we're not actually going to solve the differential equations, but we'll find some ways to understand what the solutions will look like without actually solving the differential equations, at least for some types of differential equations. In section 2.2, we look at a specific type of differential equation called separable, and we'll learn a method to solve that equation. Let's start in section 2.1. Now in this section, the first thing we'll look at are direction fields, and what they allow us to do is find what the slope of the solution curve is at any given point. So for example, if I have this differential equation, again it's first order, then at any point on the plane, say tx, any point tx, I can plug in those values for t and x, and then I can find out what dx dt, or the derivative, is. And so for example, if t is 0 and x is 1, then I would know that dx dt would be 0, or the slope of the solution curve would have to be 0 at that point, and so thus drawn here with the red arrow. The same I could do for, say, the point -1, 1, which is this point here, -1, 1, and it shows that I would get dx dt is -0.5, and so I've drawn a red arrow pointing downwards, because that means that my slope is negative, meaning that my solution would have to be decreasing there. And as you can see, I've drawn a few more arrows, and I could do that for every point on the plane. Once we have enough of these arrows, which we can calculate, then we can plot. If we knew a solution, for example, passed through a given point, in this case -2, 2, then I'd be able to know that I can draw a general approximation to my solution by following the arrows. And so for example, if it passed through here, then the blue shows me my solution curve, what it might look like by following the arrows. The second kind of differential equation that we are going to look at are autonomous first order differential equations, and these are, by autonomous we mean that the right hand side does not have the independent variable, so it only contains the dependent variable. Here y is the dependent variable, and you can see there's a y on the right, but there's no x's. In this case there's a t on the right, and so that means that I cannot determine this right here is not, this equation here is not an autonomous differential equation. Once we can understand when the derivative is positive, negative, or 0, then we can understand when the solution curve is increasing, decreasing, or constant. I'm doing a quick example. Basically the problem that we were looking at in the previous slide, the autonomous differential equation, I can find the critical points. This is one thing you'll want to do, which is by letting dy dx equals 0. In this case they're 1 and -1. And then I'll find out whether the derivative is increasing at either side of all those 2 points. And so if they're increasing, you see these upward arrows. What I've done is say plug in a 2 in here, and it lets you know whether the derivative is positive or negative. In that case it must have been positive, because you can see I have upward arrows here. If it's negative at a point in between 1 and -1, then I put downward arrows. The last thing you'll do is classify the critical points based on this phase portrait, and understand whether a point is unstable, like 1, where things move away from it, or an attractor, like -1, where things move close to it. A point may not be either a repeller or an attractor. In that case it's called semi-stable. The second type of differential equation is in section 2.2, and these are separable differential equations, and basically you have dy dx or whatever other variables is equal to a multiple of the 2 variables. Sometimes you'll have to do a little work to see that it is a separable differential equation, like in this first example, and other times it'll be clear, where you have dp dt and then you have p times 1 minus t. Again, in this case, or actually in this case, you want to go to the textbook and read about the method of solution. You'll want to be able to identify that this is separable, or that an equation is separable, and then use the specified method to solve it.